Okay, we are talking about Chapter 7, Part 3, Section 3, Similar Triangles. Now, in the previous section, we stated that in order to show that two polygons were similar, we had to show that all of the angles were congruent in pairs, and we had to show that all of the sides were proportional. Now, triangles, those are polygons, which means that in theory, ABC is similar to XYZ if and only if angle A is congruent to angle X, angle B is congruent to angle Y, angle C is congruent to angle Z, and the proportion AB is to XY as BC is to YZ as AC is to XZ is true. Now, as it turns out, much like back when we did congruence for the first time, and I told you that we had to show that every set of sides is congruent, every set of angles is congruent. Even that's not this. It's not really true. Okay, I kind of lied. No, I've been doing that a lot this year. I lied to you a little bit. Okay, there are shortcuts. We don't necessarily need to show all four of these things. There are three different shortcut rules that we can use to show triangle similarity. Okay, so we are going to go through those three rules. Each one of those rules is its own slide, and then we'll go through an example of applying those rules, and that'll be it for today. Okay, so there are three acceptable shortcuts, sort of like there were, what, 6 acceptable shortcuts for congruence, where we had, what, side, 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 angle, angle, side, angle, 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 side. We had all those shortcut rules, okay? It's the same thing for similarity. There are shortcut rules for showing similarity as well, because we don't necessarily need to show all three sets of angles. We don't necessarily need to show the entire proportion. So there are three sets of information that would be enough to declare that a pair of triangles were similar, meaning same shape, but not necessarily the same size. Those three shortcuts are angle-angle similarity, which is a postulate. We would abbreviate that as angle-angle and then the similar symbol, angle-angle similarity. We have side-side-side similarity, which would be abbreviated SSS, similar. And our third will be the side-angle side similarity. Now, the one thing we need to be very careful about here is notice that the abbreviations for these similarity postulates are almost exactly the same as congruence postulate abbreviations from Chapter 4. So if you just write SSS but don't include the tilde, the similar symbol, you're wrong. That is not the right correct thing. Okay, so you need to make sure you're including that tilde at the end of your abbreviation, because without that similar symbol, you may not be naming the correct postulate. Okay, now we're going to go through what these three postulates say one at a time. And the first one, angle-angle, is probably the easiest of the three based on what we already know. The other two require a little bit more work to be shown, but in reality, all three of these are generally fairly easy to show. They're actually easier to show than the congruence postulates were. So we'll go through these one at a time. We'll start with angle-angle similarity. The angle-angle similarity postulate, or AA tilde postulate, says that if two angles of a triangle are congruent to two angles of a second triangle, then the triangles are similar. So if angle A is congruent to angle X and angle B is congruent to angle Y, we can mark up the picture here a little bit. If we have two sets of congruent angles, then that is enough for us to go ahead and state that triangle ABC must be similar to triangle XYZ. Now, the reason why we only need two angles is because if we think about this, if we know two sets of angles, we really know all three, because every single triangle adds up to 180 degrees. So if we know two sets are the same, that third set has to be the same. We already have a theorem that says that. So the reason it's not angle, angle, angle similarity is because we don't need to prove three. If we prove two, we have really proven all three. So the angle-angle similarity postulate says if we can show that two sets of angles are congruent, that is enough. The triangles have to be similar. Next up, and I know this is going a little bit fast for those of you that are having to write the whole thing down, but I'm happy to come back later. As I've said, just hang around afterwards and ask me to put it back, and I'll put it back up, no problem. Okay, next up is the side-side-side similarity postulate. Very simple. It says if all of the corresponding side pairs of two triangles are proportional, then the triangles must be similar. In other words, if the entire proportion is true, so if AB is to DE as BC is to EF as AC is to DF, if that is a true statement, if all three of those fractions are equal, that is enough for us to state that triangle ABC must be similar to triangle DEF. So if we can write out the entire proportion and check it and make sure that it's true, that is enough for us to declare the triangles are similar. Big thing there is that is going to require a little bit of work. We are going to have an example of that, but it's not a very, none of these are very difficult to execute in practice. All right, so we got one rule to go, and this is probably the most complicated to word, and that is the side angle side similarity postulate, which says if we have two pairs of corresponding sides in a pair of triangles being proportional, as well as the included angles being congruent, that is enough to state that the triangles are similar. Now, what I mean by that is if we have just two sets of proportional sides, so if we can show that AB is to DE as BC is to EF, so if we can show that that proportion is true, and we can state definitively that the included angles, which would be angles B and E, are congruent, then that would be enough to state that the triangles are similar. So those are the rules. Those are the rules we're going to be using today in our assignment. It's a relatively simple process. We're going to go through 4 examples on the next slide to show us how to use those rules. And then we'll call it a day. You guys will be done probably about 10, 15 minutes early. I know that's heartbreaking that you won't have to stay in class all the way through to 40 or whenever this period officially ends. Okay. So on to the example. This is what your homework is going to look like as well. Now your homework is going to be on Google Forms, so it is going to be a little bit difficult to show work. Please make sure you read all the directions because you are supposed to send me a picture of your work, which you'll have to do on a separate sheet because you can't really do it on the form. The problems are going to read, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. The explain your reasoning portion is pretty simple. If you show your work and you state which rule you used, you have explained your reasoning. So the easiest, the big thing about this, the easiest thing about this is that it's always very easy to tell which rule you're supposed to be trying to use because it's all based on how many side lengths you know. For instance, if we look at that first picture, the one on the top left, you'll notice that we don't know any side lengths at all, which means we're either going to use the angle-angle similarity postulate, or it's just plain not going to work. The answer will be no. Okay? So we have to ask ourselves, do we have any congruent angles? And hopefully we all say, well, yeah. Angle L and angle M, those are both 57 degrees, right? Which means angle L is congruent to angle M because they're both 57 degrees. Now, the second set of angles, we have to be a little bit craftier. We have to think. Because the second number they gave us, those do not match. 48 is not equal to 75. But we can find the third angle in either one of these triangles. If we want to know the measure of angle K, all we have to do is subtract the two angles that we know from 180 degrees, which means that angle K is 75 degrees, which means that we have a second set of congruent angles because angle K and angle P are both 75 degrees. Now, when we get to that point, notice I've written two angle congruent statements. That means this problem is over. The answer is yes. We have shown that triangle JKL is similar to triangle. Now, be careful with your naming because remember the names have to match. So JKL would match up to QPM. Because we have shown angle-angle similarity. And we're done. The next problem should be even easier than that. On number 2, we do not know any side lengths, which means it's either angle-angle or we cannot do anything. So we have to ask ourselves, do we have any legitimate reasons why any set of angles in that picture are congruent? And hopefully, we would all recognize that we actually have enough information to state that all three sets of angles are congruent. We've got these parallel markings on RX and TW, which mean that angle X must be congruent to angle T because they're alternate interior. Using the exact same reasoning, we should be able to state that angle R and angle W are congruent because they're also alternate interior. Now, if we didn't spot both sets of alternate interior angles, hopefully we would spot the third set of angles being congruent because, well, they're vertical. So hopefully we would have that under control, that we definitely have two sets of congruent angles. In fact, we have three. We don't need three, though. We only need two. Any two would work for us as justification for us to say that, yes, triangle RXS is similar to triangle. Now, make sure you get the markings right here. We want 2 marks, 1 mark, 3 marks. So it has to be the same here, WTS. Because we have shown angle-angle similarity. So I personally would hope as your teacher that I've taught you enough geometry this year that the angle-angle problems, those ones should be really, really easy. Okay, the newer ones, the ones that are a little bit more difficult in my opinion because we don't have as much experience with them, are the other two problem types, side, 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 and side, angle, side. So if we look at number 3, we should see that we know information about every side in the entire picture. We know all 3 sides of both triangles, which means we should check the side, side, side similarity postulate. We should check to see if all 3 sets of sides are proportional. Now, the hard part is getting them matched up correctly. But I'll point out that it's as simple as smallest over smallest equals middle over middle equals biggest over biggest. So the smallest side in this triangle is 6. Smallest side in this triangle is 8. So we'd say 6 over 8. Does that equal? The middle length here is 9. The middle length here is 12. 9 over 12. Is that equal to the biggest length, 12, to the biggest length, 16? And all we have to do is confirm that those 3 fractions are in fact equal. So all we have to do is reduce those three fractions. All three of those fractions reduce to 3/4. Remember that 3/4 is called the scale factor. But all three of those fractions are equal to 3/4, which means, yes, these triangles are congruent. Triangle JKL is similar to triangle. This is probably the hardest part in the whole thing, is getting the name right here. So when we say JKL, JK is the biggest side. So we need to put QP and then M. And if you look, that's probably the hardest part, is figuring out the order there. J has the 2 circle and the 3 circle on either side of the angle. So it matches Q, which has the 2 circles and the 3 circles on each side. See what I'm saying? Got to get those matched up right. Because we have shown side, side, side similarity. If even one of those 3 fractions is not equal, then it's a no. They all 3 have to be the same fraction. Okay? Which brings us to the last example. Notice in the last example, we do not know all 3 sides. We only know 2 of them. So that means we're going to be using side angle side, because we know 2 sets of sides, not 3. So we're going to set up that same sort of proportion. We're going to check to see if 10 over 20, those are the smaller of the 2 sides, is equal to 11 over 22. So we check that proportion. That proportion is true. Both of those fractions are equal to 1/2. And then the other thing that we have to confirm, and we have to give a reason for, is the included angles between those sets of sides have to be congruent. Well, that would be angle TWZ, which is here, and angle YWX, which is here. Those 2 angles, I hope everybody would recognize, are definitely congruent because they are vertical. So because those are vertical angles, the vertical angle theorem says they must be congruent. So we have shown 2 sets of proportional sides as well as a congruent included angle. That would mean that this is also a yes. Triangle TWZ is similar to triangle YWX by side angle side similarity. Okay. So that is the first half of the lesson.